Hey everyone, welcome back to another session of our CISSP study group. I'm B-Dubs and I'm excited to talk about all these topics with you today. Whether you're preparing for the CISSP exam or you're just a nerd about cybersecurity, you're in the right place. It's so exciting to see you here and I'm thrilled to be on this journey with you. In our last session, we dove into Domain 8 with objectives 8.1 and 8.2. If you missed it, don't worry. I've got a playlist to help you catch up at your own pace. I'll share the link in chat now. Today, we're finishing up Domain 8 with objectives 8.3, 8.4, and 8.5. So let's get right to it. Today, we'll cover objectives 8.3, assess the effectiveness of software security, 8.4, assess security impact of acquired software, and 8.5, define and apply secure coding guidelines and standards. These objectives are all about securing software through testing, vetting your external tools, and implementing secure coding practices. Think of it as a three-step approach. We test our existing systems, evaluate any software we acquire, and build security into our code from the ground up. So grab your monster and let's dive in. Before we dive into the details, let's discuss why software security is critical. Think of your software as both a medieval castle and a modern smart home system. If either has weak security, attackers can easily breach it. Just like a smart home needs secure door locks, cameras, and network protection, our software requires multiple layers of defense. The 2017 Equifax breach illustrates this perfectly. An unpatched vulnerability led to 147 million people's data being exposed. This shows how software vulnerabilities, such as SQL injection or cross-site scripting, can result in devastating breaches, often costing companies millions in damages and lost trust. This connects directly to what we covered in Domain 1 about risk management, in Domain 3's security architecture principles. As a CISSP professional, you serve as both the architects designing secure systems and guards protecting them. This domain provides the practical tools we need to build and protect our digital assets, making it critical for both passing the exam and handling real-world scenarios. Jumping straight into Objective 8.3, assessing the effectiveness of software security. This is about making sure our security measures actually work. They must withstand real threats and effectively control risk. Think of it like a door lock. You wouldn't trust it without testing it first. There's a few components here you need to know for the exam. First, we have our auditing and logging. Think of this as your security camera system. Just as cameras record everyone entering and leaving a building, our logs track every action in our systems. For example, when someone tries multiple failed login attempts, or when an admin modifies a critical security setting, it's all logged and recorded. These logs are important because they let us replay the tape if something goes wrong, helping us understand exactly what happened. Then we have our risk analysis and testing. This is where we're basically playing chess with potential hackers, thinking several moves ahead. We ask ourselves, what would an attacker do? How would they try and breach our defenses? But we don't rely solely on imagination. We use powerful automated tools like SAST for code analysis and DAST for testing running applications. To measure effectiveness, we track metrics like mean time to detect, which measures how quickly we can spot issues. Just remember that if we don't test our security, we're only hoping it works. And hope isn't a strategy. Just as we test a lock through picking, stress testing, and examining the weak points, we need multiple approaches to verify our security strength. Now we have three main testing approaches to verify that our security is working. First, we have penetration testing. This is where we bring in our ethical hackers, our good guy attackers. Unlike regular security assessments that just point out weaknesses, pen testers actively try to exploit vulnerabilities. They demonstrate exactly how a malicious threat actor might compromise our system, providing invaluable insights for strengthening our defenses. Then black box testing is where we put on our hacker hat and try to break in from the outside without any knowledge of the internal code. We use specialized tools like Burp Suite to simulate real-world attacks. This is important because it mirrors how actual attackers would approach our system. Finally, there's white box testing. Think of this like having X-ray vision into our code. We can see everything, every line, every function, We use powerful tools to analyze the code while we're building it. It's like inspecting every brick while constructing a house, making sure each one is solid. Now we integrate these approaches into DevSecOps with continuous security testing through automated pipelines. While functional testing makes sure that the software works, dedicated security testing identifies vulnerabilities. Code signing adds a digital seal using PKI certificates, providing both authenticity and integrity throughout the software supply chain. Finally, we have certification and accreditation. Certification thoroughly verifies compliance with security standards, while accreditation provides the official stamp of approval for use. This all ties back to what we learned in Domain 6. So now we move into Objective 8.4, assessing the security impact of acquired software. This covers anything we didn't build, like commercial off-the-shelf products or COTS, open source code, third-party apps, or managed services like SaaS or AWS. Each comes with its own security considerations and risks that need thorough evaluation. So why is this tricky? Well, since we didn't write it, we're not completely sure what's inside. It's like buying a used car. You've got to check under the hood, verify the maintenance history, and get an independent inspection before trusting it. Security is still our job, so we dig in deep using a systematic approach. So how do we make sure our acquired software is safe? Let's walk through these 4 types of software we need to assess. First up is COTS, or commercial off-the-shelf software. Think about products like Microsoft 365. What are we looking for here? With COTS, we need to verify the vendor's security credentials. These are things like ISO 27001 or SOC 2 certifications. Pay close attention to patch schedules and support terms. We'll also want to review their security documentation and take a look at their track record for handling security incidents. One important consideration here is source code escrow. Think of it as an insurance policy. If the vendor goes bankrupt or discontinues the product, you'll still have access to the source code, making sure you have business continuity. Next, we have open source software, like Linux. While the code's public nature offers great transparency, we need to be extra vigilant about a few things here. Watch out for supply chain attacks in the dependencies. Monitor known vulnerabilities. Tools like Sneak are fantastic for this. And check the update frequency and community support. Watch out for abandoned projects or any suspicious code changes. The bonus here is that we can review and modify this code if needed. Remember that an abandoned project here can be a security nightmare. The third category is third-party software. Think custom applications from contractors. Here's the key. We treat it exactly like our own code and apply the full SDLC security testing. That means thorough code reviews, comprehensive security testing, and strict compliance verification. Watch out for unauthorized access risk and poor maintenance. These can break your security. And finally, we have managed services. This is where things get interesting because it operates on that shared responsibility model. You have to really know and understand exactly which security tasks are yours versus the provider's. Take AWS, for example. Depending on whether we're using an IaaS, a PaaS, or a SaaS service, they might handle the physical security and infrastructure. But then we're still responsible for securing our applications and data that run on their platform. Also, don't forget to check data residency requirements and SLAs. They're essential for compliance and security. Now moving on to Objective 8.5, our final exam objective, defining and applying secure coding guidelines and standards. This is about writing code that's secure from the start. I mean, why patch holes later when we can build it right the first time? To make this happen, we need to focus on these key areas. First up is the security weaknesses. This includes things like the OWASP Top 10. These are the most critical and most common security risks you'll encounter. Next, we need to secure our APIs. Think of APIs as the doors to your application. We need strong locks, that's our authentication, and careful checking of everyone who comes through. That's our validation. Then we need to follow secure coding practices. Following established guidelines helps prevent common vulnerabilities and make sure we have consistent security implementation across our projects. Finally, we have software-defined security. We'll explore how to automate security in cloud environments. This is where modern security is heading. Remember that fixing a breach after the fact is like mopping during a flood, so let's prevent it instead. Let's start by looking into some common security vulnerabilities that you need to be aware of. We're going to break them down into 3 categories. First, data security issues. The buffer overflow is one of the most dangerous vulnerabilities. Think of pouring too much water into a glass. When attackers overflow a buffer with excess data, they can potentially inject malicious code. SQL injection lets attackers sneak unauthorized commands into database queries. Then there's memory reuse, where sensitive data like encryption keys or passwords can persist in memory if not properly cleared. Next up is implementation flaws. For APIs, proper authentication is critical. Race conditions are tricky. These TOC, TOU, or time of check to time of use vulnerabilities happen when there's a gap between checking something and using it. Another critical issue is malformed inputs. Always validate and sanitize user input, treating it like a suspicious package that needs thorough inspection. Finally, process and people issues. Developer backdoors are a real concern, which is why we need strict code review processes. With the rise of citizen developers, which are business users creating their own applications, proper security training and guidelines are essential. Remember that security is not only as strong as your weakest link, and that's often the human element. So let's focus in on API security for a minute. This is important because APIs are basically the bridges between our applications. Here are the essential security measures you need. First up is authentication. We want token-based auth, specifically OAuth 2. Why? Well, because it provides proper expiration and scope validation, like a VIP pass that expires and only works for specific areas. Next comes encryption. TLS version 1.2 minimum for all traffic. This is non-negotiable. Think of it as an armored car for your data. Anything less isn't secure enough today. Then we have input validation. We need strict validation against any type of injection attacks. Never ever trust user input. Always validate everything that comes through your API. Finally, implement rate limiting. A good rule of thumb is maybe 100 requests per minute, but this might need to be more or less depending on the job of your API. This prevents abuse and maintains service availability. Think of it as crowd control to prevent everyone from rushing through the door all at once. REST APIs need careful security. Enforce HTTPS, validate JWT tokens, and implement proper CORS policies. SOAP APIs provide built-in security through WS security standards. These are perfect for enterprise scenarios requiring message-level security. Remember that APIs are prime attack targets, so validate everything and maintain extensive logging here. Now let's look at some secure coding principles based on OWASP and CERT best practices. These are the minimum guidelines you'll want to follow. Input validation is absolutely crucial. Always validate that your inputs match what you're expecting. If you're looking for a number, make sure it's actually a number. This might seem basic, but it's your first line of defense. Remember to never trust your user input. If a user can type it, they can try to hack it. So always verify everything that comes into your system. For authentication, you'll want strong MFA and properly salted password hashes. At the very minimum, your passwords should be at least 12 characters, include special characters, numbers, and both upper and lower case. Session management requires secure cookies and fresh session IDs. Set critical flags like HTTP only to prevent cross-site scripting attacks. Secure to ensure HTTPS, and same site equals strict to prevent CSRF. Don't forget session timeouts either. 15 to 30 minutes of inactivity is standard here. For error handling, this is about failing gracefully and securely. When something goes wrong, and trust me, things will go wrong, your application needs to handle it smoothly without exposing sensitive information to potential attackers. Be vague to users, but detailed in your logs. Never expose sensitive information in error messages, but keep detailed logs for your team's troubleshooting. Now, memory management is how we prevent those nasty buffer overflows that hackers just love to exploit. Think of it like filling a cup. You need to know exactly how much space you have and never try to pour in more than it can hold. Use safe functions and always validate buffer sizes. Most importantly, zero out sensitive data when you're done with it. For your cryptography, you need to implement modern encryption both in transit and at rest. You should be using at least AES 256 for symmetric encryption, RSA 2048 or better for asymmetric, and SHA 256 or better for hashing. Access control follows the principle of least privilege. Only give access to what's absolutely necessary, nothing more, and avoid running any unnecessary services. For file and database security, implement strong access controls and encryption. Use parameterized queries to prevent SQL injection. Encrypt sensitive data and validate file types before processing them. Finally, dependency management. Often overlooked, but so important. Keep your libraries updated and verified. Tools like Sneak or OWASP Dependency Check can automate this process for you. Now, these common vulnerabilities come from several key sources. This includes inadequate security training, weak code review processes, rushing to meet deadlines at the expense of security, and accumulated technical debt. Organizations can prevent these issues by making secure coding training mandatory, implementing automated analysis tools, performing regular security assessments, and establishing clear security requirements throughout the software development lifecycle, or SDLC. Remember that preventing issues through education and robust processes is far more effective than fixing bugs after the fact. Now, there's two other important architectural concepts that can significantly impact security. The first one is coupling and cohesion. Imagine you're building a secure login system. When we talk about high cohesion, each module has one clear job. Keep in mind that we're talking about software security here, and a module is a component of a software system. For example, our authentication module only handles user verification, nothing else. Low coupling means that these modules communicate through clean, well-defined interfaces. It's like having a well-organized team where everyone knows their role and how to communicate effectively. This structure makes our system much easier to secure because we can quickly spot and fix vulnerabilities. The second concept is polyinstantiation, and it's fascinating. Think about a classified document system. Executives can see the complete document. Managers see a partially redacted version, and other employees see only the public information, all from the same database. Think of it as different layers of access to the same information, making sure that everyone sees only what they're authorized to see. This is important for preventing information leakage between security levels. Now, software-defined security brings automated, programmable protection to modern infrastructure. Think of it as your tireless digital guard working 24/7 to protect your systems. So what makes it so powerful? First, it has dynamic security controls. These aren't just static rules either. They learn and adapt to new threats in real time. Then we've got programmable network security groups, which automatically adjust security settings based on network activity. Automated incident response rules are impressive. When something suspicious happens, software-defined security springs into action immediately, without waiting for human intervention. And finally, real-time policy updates. Need to change your security stance? Boom. The changes apply across your entire system instantly. It's perfect for cloud environments. Software-defined security enables centralized management while reducing human error through automation. This integrates seamlessly with DevSecOps, making security both future-proof and scalable. All right, let's wrap up today's session by highlighting our three main takeaways. First, for Objective 8.3 on security testing, we need a comprehensive approach. No single method will suffice. We must combine regular audits, detailed threat modeling, and continuous assessment to make sure that our security controls are working effectively. For Objective 8.4, software acquisition, thoroughness is key when bringing in any external software, whether it's third-party, open source, or managed services. This means conducting detailed security reviews, carefully checking documentation, and implementing ongoing monitoring. Think of it as doing your due diligence both before and after introducing new software into your environment. Finally, for Objective 8.5, secure development. Remember this key principle. Security must be built in from the start. It's not something we can just bolt on at the end. Focus on those critical areas we discussed: proper input validation, securing your APIs, implementing robust error handling, and making sure automated testing is in place. These form your foundation for secure development. Security is a lifestyle. Live it, breathe it, and you'll crush the exam. Now that's all I have today for objectives 8.3, 8.4, and 8.5. We've now completed Domain 8 and now all the domains for the CISSP exam. You're crushing the CISSP journey. Keep that momentum going. If you need to review anything, no worries. These recordings stay on YouTube, and I'll add chapters after the stream so you can easily jump to specific topics. Mastering these concepts is a huge step towards your CISSP certification. And since they'll keep appearing, make sure to connect them to real-world scenarios. Stay curious and keep practicing. You're doing fantastic. Now who's ready for the after party? I'm heading to our Study GRC Discord server's CISSP voice channel right now. It's perfect for questions, insights, and connecting with our community. If you're not in Discord yet, you can visit cissp.britwhite.io for the Discord link. And don't forget to grab your CISSP role when you join to get full access to our study channels. Our last and final session for the study group will be Saturday, June 14th at 3 p.m. US Central Time. We'll review essential exam tips and tricks. You won't want to miss it. Thanks for watching, and I'll see you in Discord.